In this lesson, I'm going to show you how to verify inverses by using function composition. I will encourage you to watch video on function composition if you are not familiar with the concept. So by the end of the lesson, you will learn how to show or verify that two given functions are inverses by using the function composition. There's a unique property when two functions are inverses. So that is because when you compose the function, you are always going to get x. So if f and g are inverses, and I compose the function f and g, I will always get x. And why is that? Is because when two functions are inverses, so when you now compose those functions, it's as if you are using them to cancel each other out. So at the end of the day, you will end up with the line y equals to x. Sometimes they might also use the function notation. The function notation tells you that f of s and the inverse of f of s, if you compose them, you are going to get x. So this question says we should use the composition to show whether f and g given to us in this question, whether they are inverses. The key word is use composition. We want to find f of g and we want to verify, is this equals to x? If it is yes, then that means they are inverses. If it is no, then that means they are not inverses. So let's do the function composition. So our f of x is 2x minus 5. So now we want to find f of g. We just need to stick this value into the g. Our f of g will now be equals to 2 multiplied by g. The entire g is x plus 5 divided by 2. And please don't forget the minus 5. So we now need to simplify this. So these two can cancel these two out because this is dividing, this is multiplying. So then we are left with f of g equals to x plus 5 minus 5. And as you can see, 5 minus 5 is 0. So f of g is x. So that means in this case, yes, f and g are inverses. Okay, so that's the solution in this case. So I want you to use this practice question to show or to demonstrate to yourself that you are able to follow me in this video. So example 2, we want to use the composition of function to also determine if f and g are inverses. So again, all we need to do here is just to find f of g. So what is our f of g? So our f is f of x equals to x minus 5. Okay, so instead of just x, now we want g. So that this will be g minus 5. So g is 5 minus x. So f of g is 5 minus x minus 5. So in this case, we open up the parentheses. F of g will be 5 minus x minus 5. So the 5 minus 5 will be 0. So f of g in this case is negative x. So f and g in this case are not inverses. So I need you to use this question to practice this example. So in example 3, we are given f and g again. So let's compose them. So f of g is going to be equals to x. Let's find out. Again, start with f of x equals to x minus 7. Okay. So f of our g will be g minus 7. So in this case, our g is s plus 7 minus 7. So you can see already, this will be s plus 7 minus 7. So 7 minus 7 goes to 0. So in this case, f of g equals to x. So yes. So in this case, F and G are inverses. So I need you to use this question to practice this particular example. So we are given these two functions. Our f of x equals to the cube root of 4x plus 1. So we want to find f of g. Okay, so f of g is going to be the cube root of 4g plus 1. So we now need to put the entire g into the cube root. So this will be cube root of 4 multiplied by x raised to the power of 3 minus 1 divided by 4. So that's our g plus 1. So don't forget the positive 1. So what do we have here? 4 cancels out 4 inside the cube root. So f of g equals to cube root of x raised to the power of 3 minus 1 plus 1. So 1 minus 1 goes to 0. So now we have f of g equals to the cube root of x raised to the power of 3. So the cube root, we cancel out the cubic. So in this case, our f of g will be x. F and g are inverses. So I need you to use this question to practice this particular example. Thank you so much. Please remember to subscribe to this channel.